Good day, everyone. Let's now have the limit superior and the limit inferior of the sequence. So if a sequence of real numbers, if this is a sequence of real numbers, then the limit superior of the sequence is given by this one. This is the lim sup for short, which is equal to the infimum of the supremum of x sub k, where k is greater than or equal to n for all n, which is equal to this one, where n is a natural number. Okay, to illustrate this one, let's have this. So we have lim sup of x sub n is equal to the infimum of the supremum of x sub k, where k is greater than n, such that n is a natural number. Now let's have this first, this one, the supremum. Let us have this s sub 1 be equal to when n is 1. So when n is 1, we have this s sub 1, which is the supremum of x sub k, where k is greater than or equal to 1. So we are to find the supremum of this sequence where k is greater than or equal to 1. Next to that is when n is 2, s sub 2 is the supremum of x sub k, where k is greater than or equal to 2. So we will get another supremum of this sequence such that k is greater than or equal to 2. And so on, s sub n, which is equal to the supremum of x sub k, where k is greater than or equal to n, and so on. It's because n here is a natural number, so up to infinity. Now try to observe here. We have here another sequence here, s sub 1, s sub 2, s sub and so on. So these are the supremum. Notice that s sub 1 is greater than or equal to s sub 2. Why? Because in this sequence, we got the supremum of this sequence where k is greater than or equal to 1. So nakuha na to siya ang supremum. It could be in the next na sequence, pwede siya, si s sub 2 is smaller, or it could be equal if napaghapi the same na number na pareho sa supremum sa s sub 1. And so on. So we have s sub 3, s sub 2 is greater than or equal to s sub 3, and so on, s sub n, and so on. So that's the behavior of our sequence, s sub 1, s sub 2, and s sub n. And then after that one, we will get the infimum. So next is to get the infimum of this sequence here, s sub 1, s sub 2, s sub 3, s sub n, and so on. So this is just equal to the limit of s sub n for all n. So that is the lim sup of x sub n. Okay. So let's have here the remark. So of course I have discussed this. So we have here, okay, this one. So it's already, I'm done discussing this one. Now let's have here our example. We are to find the limit superior of this sequence. So this sequence is the same as when n is 1, negative 1, 1, 1, 1. So this is our sequence. So first that we're going to find is S sub 1. So S sub 1 is equal to the supremum of these two numbers. Take note that if we have this set here, negative 1, 1, negative 1, 1, and so on, this is the same as writing negative 1, 1. So negative 1 and 1 are repeated, so we can write that in this way. So of course, as you can see, the supremum of the two numbers is 1. Here, the same thing, because 1 is repeated infinity. There are infinite numbers of terms of 1. So 1 and up to n is 1 for all n, and so on. Therefore, the lim sup of x sub n, the sequence x sub n, this is x sub n, is equal to the infimum of s sub n for all n, which is the infimum of s sub n is 1. Therefore, the limit superior of the sequence is 1. So let's have another definition for the limit inferior. If x sub n is a sequence of real numbers, then the limit inferior of the sequence is given by this one, the symbol, and bar is below the lim symbol. So this is the lim inf of x sub n, which is equal to sup of inf, supremum of the infimum of x sub k, where k is greater than or equal to n for all n, which is equal to the supremum of the infimum of this. So this is most likely the same as what I have illustrated a while ago. So here, the symbol lim x sub n is equal to the supremum of the infimum of x sub k, where k is greater than or equal to n, such that n is a natural number. Here again, if n is equal to 1, let's have here L sub 1 is equal to, let us try to consider this one, the infimum of x sub k, where k is greater than or equal to 1. Next one, L sub 2, when n is 2. So this is the infimum of x sub k, where k is greater than or equal to 2. So if we have L sub n, so this is the infimum of x sub k, where k is greater than or equal to n, and so on. Notice here, we have here the sequence. We have L sub 1, because this is the infimum. We will get the smallest number, or small, when we say infimum, the greatest lower bound. So the greatest lower bounds. And then, nakuha na siya. Of course, this number is less than or equal to L sub 2, less than or equal to, and so on. L sub n, less than or equal to, and so on. So notice this, that this sequence is increasing. Increasing na kay infimum na itong ikuha. Nakuha na itong infimum, and then itong gamay nga value, and then the next could be greater than or equal to this one, and so on. So we have now the supremum of here L1, L2, Ln, and so on is equal to the limit of L sub n as n approaches infinity, which is equal to the limit inferior of the sequence. So let's consider the remark here. we have, of course, the sequence is increasing here, and then the limit superior is this one, as illustrated a while ago. So let's have here an example. So to find the limit inferior of this sequence, again, the same sequence. So let's try to find L sub 1. So of course, infimum smaller is -1. We have another one is still -1 because there are infinitely many terms of -1. Then -1 up to L sub n, still -1 for all n. So the limit inferior of x sub n is the supremum of Ln for all n. So supremum of Ln is of course -1. So the limits inferior of this sequence is -1. And that's it.